Okay, here we go. We are covering the last unit in chapter 6. It's been I feel like we've kind of flown through chapter 6, but so much of what we do in these, especially these last few lessons, is like it's basically the same things. We're just making different applications of the same things that we learned. So we're doing it kind of over and over. In this lesson, we're doing indirect measurement. And indirect measurement allows you to use the properties of similar triangles, which we did a whole lesson on similar shapes. Then we kind of used those things in the last lesson that we did with dilations. We used those same properties when we were talking about scale and scale factor and models and those kind of things. So they all go hand in hand, they all work together. Those properties of similar triangles to find measurements that are difficult to measure directly. So we're going to be looking at how we can use things that we can measure to find the distance of things that we can't measure, or the distance that we know to find the distance that we don't know. Maybe the height of a person, we can use that height to find the height of a building, and those kind of things. It's hard to measure the height of a building, kind of easy to measure the height of a person. So we're going to look at just some examples, launch straight into what we're doing. This is called shadow reckoning, using the length of a shadow to and comparing it as a proportion to the length of an unknown object to be able to figure out what the height of that object is. A lead statue of a Korean War memorial in Washington, D.C. casts a 43.5-inch shadow. And let me reset. Oh, I got rid of something that was on there. So the shadow, change colors. The shadow here on the ground is 43.5 inches long. At the same time, a nearby tourist casts a 32-inch shadow. So this guy's shadow on the ground is 32 inches. If the tourist is 64 inches tall, so this guy, his height is 64 inches, then what is the height of this statue? How tall is the statue?
8.
And hold on. You guys are throwing numbers out. I've told you before, I use easy numbers on the first example so that we can set up the process for solving it. I want to show you how to set up the proportion, not just throw numbers out there. We have to set up the proportion involving corresponding parts of the similar figures. So what two things correspond that we know the heights, the lengths of? We know the lengths of the shadows, and shadows correspond to one another. So we can set up the lengths of the shadows as a proportion, 43.5, and then we can use the corresponding heights to figure out the height of the statue. So since 32 is on top here, that's the shadow of the man, where does his height go? Or on top, 64 over x. 64 times 43.5 divided by 32 equals the number that you were all trying to shout out just a minute ago. 87 inches. So yes, the statue is 87 inches. And I understand, because you're all very smart, and you see the pattern that this guy is twice as tall as the shadow, so this thing must be twice as tall as the shadow. That's a good, I'm happy that you see that relationship, that you can jump to that conclusion that quickly. That works in this case because these numbers are easy to see that with. This works every time. This will never fail you. Okay, so I want you to concentrate on the process, not on observing a quick answer just because this one was easy. All right, so the process is what we're worried about here. Use indirect measurement to find the distance from the mess hall to the cabin. So the cabin is here. You may not be able to see these at the back very easy. Cabin is here, this is the mess hall, so we're looking for this distance, and we know these distances. So we can set up some proportions. This side here, TR, is 46 yards, and it corresponds on this triangle to SR, which is 138 yards. And we can set that up as a proportion, and this side from RU is 60 yards, and we don't know the distance from R to Q. So that is X. 60 times 138 divided by 46. 180 yards.
That far.
Okay. Do you see the similarities between what we're doing here and what we've done the last couple of lessons? With similar figures, just finding those sides that correspond to one another and setting up the proportion, right? Okay, a basketball hoop in Miguel's backyard casts a shadow that is 8 feet long. At the same time, Miguel casts a shadow that is 4.5 feet long. So the shadows, 8 feet and 4.5 feet, they correspond to one another. 8 over 4.5. If Miguel is 5.5 feet tall, how tall is basketball hoop? Round to the nearest tenth. So it equals what? X over 5.5. Since Miguel's shadow is on the bottom, Miguel's height needs to be on the bottom. So 5.5 times 8 divided by 4.5.
9.77.
X equals 9.8 since we're rounding to the nearest tenth. 9.8 feet. Miguel does not have a regulation basketball hoop. All right, let's find the distance of Kentucky Lane on this one. If you've got, stretch that out a bit so you can see it better. If you've got this distance 4 miles and this distance 6 miles, then what corresponds with 4 miles? 8. Where'd you get an 8 at? Because from here to here is 4 and from here to here is 4. So the total distance then is 8. Good. Sometimes you have to make those, draw those conclusions. So 4 over 8 equals what?
Wouldn't it just be 8 over x? 6 over x.
6. This is a 6. So 6 over x. Good. This is another one that's pretty easy to see the relationship. X equals 12 miles.
Kentucky Lane's 12 miles long.
Okay, so Kentucky Lane is 12 miles long. All right, we've got some more shadows here. This cat or dog or whatever it is, and a tree. So what two things correspond?
0.3 and 2.2.
The shadows correspond, so 0.3 and 2.2 equals 0.45 over x. 0.45 times 2.2 divided by 3. How much?
3.3.
3.3
No,
meters.
0.33.
0.33, okay.
That would have to be.
Well, the tree can't be shorter than the rabbit or the dog or the cat or whatever that is. So you gotta have, you're missing a decimal point somewhere. 0.45 times 2.2 divided by 0.3.
3.3. Okay.
Okay. All right. And you can tell the relation, this cat's height is taller than its shadow. So when you do this, when you find this height, is it going to be taller or shorter than its own shadow?
Shorter.
It's got to, if the cat is taller than its shadow, then the tree has to be taller than its shadow.
It does.
Yeah, that's the proportion, that's the relationship.
Makes sense. I don't know my calculator.
It makes more sense.
You just missed a decimal point somewhere, is all you did. All right. All right. Again, we've got triangles. So 3 meters by 5 meters is this triangle. This triangle is 62 meters by some unknown distance. So the 3 corresponds to what?
The 62.
3 over 62 equals 5 over D. 100 and what?
103.3.
103.3 meters. Okay.
Would it be 100?
Round to the nearest.
I know, but if it's 3.
That water
What
is
did you put
deep.
4? No, because 3 rounds down.
That water's around 320 feet deep.
5 and up rounds up.
Okay.
If it's 4,
All right.
3, 2, 1, 0, it rounds down.
Last one, sometimes they just give you the words, they don't give you a picture, so what can you do? Draw a quick picture, and it doesn't have to be a fancy picture. The height of a school building is 25 feet tall. Here's a school building, it's 25 feet. I don't even need a square, just a line, 25 feet. A mailbox outside the school is 4 feet tall. The mailbox casts a shadow that is 6 feet long. What is the length of the shadow of the school building? Now, before you start throwing numbers, let me ask you this. Is the shadow going to be more or less than 25 feet?
More.
Why more?
Because the shadow of the mailbox is more.
Since the shadow of the mailbox is longer than the height of the mailbox, then the shadow of the building has to be further than the height of the building. So if you set up your proportion, you come up with a number 12 on this, or number 6 or something, you know you've done something wrong, because this shadow has to be longer than the height of the building. So that's one way to check your solution to see if you're getting things right, okay? So help me set this up then.
4 over 25.
4 over 25
Equals 6 over x.
equals 6 over x.
And it equals 37.
X equals 37.5 feet. Don't forget to label your answers on this. They're all going to be distances. You need to label your measurements. Here is your assignment. 12 problems from your book. You got this.